for some reason, I had to quit and restart the software. So no chance this would have worked any other way. But to go back to what we're saying, Pocket Flow is this pretty great, pretty great kind of pattern to build agents, which I like. I saw that there's been like some PRs, but like whoever cares. I am going to go actually to my either port cookbooks to Go cookbook or add Go version. Well, we'll see. I don't remember which version I was at, but I basically ported the pattern of Pocket Flow, which we're going to look at, to Go, and I added it to be event driven. So that's the main point. I want everything to be event driven because this allows me to scale, allows me to do async stuff pretty easily, allows me to use a ton of little features while keeping the possibility of making things synchronous. So we'll be looking at this. The core abstraction here is that you have a node. A node has 3 steps. It has a shared store that it can prepare to create argument for an execution function, and then post-process data that is going to be written back to the shared store. And a flow is going to be used to orchestrate like what happens after the post action returns. It returns an action string, which determines which node is next going to be triggered. And we're going to open this project in Cursor, and with Sonnet 4, which came out today, I think I was able to cook some pretty crazy stuff today. And it one-shot like stuff that I didn't think was one-shottable. Is really exciting because it is even like closer to me being able to formulate the ideas that I have and have them implemented. And I'm kind of like a system thinker. Like I think in structures and I think in shapes. It's like kind of hard to explain, but it's like kind of like multi-dimensional shapes that work against each other or not. And then based on that, the APIs that I want to have kind of appear, but then of course I do have like a lot of work to do. And sometimes I don't have the right shapes and I just like keep banging my head against something that I know is possible, but I can't find the right abstraction. And for agents, I think this Pocket Flow might be at least the next step of me searching for a good abstraction. And so that is really, really exciting to me. And the third thing we're going to do is basically look back to where we're at. We're on the experiments Go version branch. There is a branch from Codex, which I think is pretty interesting because I think I did that as a Codex experiment and I haven't looked at it yet. So I think if we look at the Codex branch, which I tried the other way, it's like straight on top of the commit that I have, and I asked it to add new patterns. So since we have uncommitted things here as well, this is going to be interesting because I changed the fundamental API to be a little bit different here. So I actually don't remember if this ever ran, if it ran correctly, but to show you where we're at, the pattern that I'm kind of like using, or like the example that I'm kind of using, is a simple branching agent. So we do have a simple input node, right, where I as a user supposedly input something, and then we have an intent classifier node, which is going to call an LLM and say like, oh, what's the intent of doing this? And then route this to a weather node, right? Like there can be an intent of looking for the weather, of asking for time, of asking for help, or just like a general pattern. And so this is how you define the agent, right? You have a flow builder, which is called branching. You begin at the input node. You then go into the intent classifier node, and then you dispatch based on the action string that comes back. You route to a whole set of different nodes, which then I think just finish the flow. And then compared to the Python, this is all a little bit more verbose because it's Go, but we do have an intent classifier node. We do have a weather handler, and then we have a time handler. And so maybe we should rename those to help node. And I don't know where they're called node. I think it's because you do have to call them with, where does the handler actually get passed in? That is quite interesting. I think this is missing. So I don't remember how far I got, and this is like the downside of doing a ton of experimentation with LLMs, where I was playing with these interfaces and try to kind of like see where they go, is like probably it lost like a core functionality in all of this, which is like maybe not the best thing that could have happened. So I'm not sure about this like core node interface here, because we do have node workers, which are then used to actually make this flow. And I'm not really sure how this all like fit together and if it even makes sense, because it looks like here, these workers are never like kind of instantiated. So we'll see. We'll see if any of this still makes sense and go back to something that actually worked. I think what we have here is that we do register nodes at some point. Right? Like we create node workers, and node worker is like a better name for node. Maybe it's like all a little bit confused. And maybe that's where we should start with Sonnet 4, right? Sonnet 4 being like super crazy clever, as we can maybe see, not only did I ask it previously in a previous Ampcode, and that's maybe where it destroyed everything. We're going to ask it to clean things up, and then if we really get lost, we'll just like start from scratch, right? Like there is value in just throwing everything away, or like maybe reverting to something different. And so this is the API that we have as a long-term document, and I think this is just like maybe not perfect. I think having this be part of the node and not the node worker might be maybe a little bit better. And the first thing we're going to do, maybe just to like actually also see how good Sonnet is, and maybe we'll do the same with Opus even, is maybe put together like a nice little concise element of how these nodes core abstractions work. Maybe they're also already here, right? Like we do have a node MD file, which is the core abstraction, which is what we're looking at. So maybe we could use this current implementation that we have and say like, look, this is not very elegant. I'm confused by the node workers. I'm confused by the flow workers. Can we somehow group these two things together to make them easier to handle, and then refer to our branching example and say like, look, this is kind of what I want to build. Can we make this a little bit prettier, right? So we're going to say, I think 07 long-term documents, so the long-term document that documents our architecture is messy, and I think maybe the worker structs, the worker interfaces could be merged with the node flow interfaces. This is a Python port. This is a Go port of the Python design pattern for Pocket Flow, except async C, and then we're going to link like the original documentation. I'm not sure this is like the best idea, but why not? Core abstraction of the node, the flow, and maybe communication async parallel. Like that's not something we need to bother ourselves with here. And what I want to do now is like, I want to have a really elegant way of specifying a branching workflow like branch flow. So this is, at this point, we added like a lot of LLM slop, a lot of LLM like craziness on top of each other, such as I actually don't understand and remember what I did, which is a common problem at the speed of development that I'm even doing right like these days, is I just do too much. I do too much without really looking into the details. And I think it's perfectly fine to do that. I think it's perfectly fine to waste, a lot of work, a whole session of code, if you get a lot of raw material that you can then crystallize into one single document that you're going to keep and then rewind everything, right? And because so much has been written already, right? Like if I go into the repo and I compare this to the main branch, if I look at the part where we branched off is here. If I compare the number of code the size of the code we've been writing since then, we can see this is like 9,000 lines of code. We can see there's like a ton of documentation that we've been building here. And then there's a bunch of like implementation with some examples, right? And maybe, especially the implementation part, maybe there's a lot we can just like kill here. Because what we care about ultimately, right, is like the API of all of this. And if we end up having a nice API, then we can kind of throw everything away if it's too hard to understand it, or we don't remember, or it gets like messy, and just like recreate it from scratch. Because especially it looks like Sonnet 4, from what I've played with today, is really good at creating things from scratch in one go, right? And so here, these documents here are a little bit messy, and this is something that I personally need to work with, is like when I do all of these experiments and I generate a lot of slop, because all of this is LLM slop, right? Like I didn't go in, read it carefully, edit it. I just like generate material until I feel I have like something that allows me to do a good implementation. We'll have to see because I don't know if these documents are like good or not. And I definitely have ideas for a system to, just like mark the quality of these things and say like, well, this was not all that useful. Maybe it shouldn't be used again, those kinds of things. So anyway, we'll see. I want to have a elegant way of specifying a branching workflow, like Go, event examples, branching flow, and maybe we can see if this is something that also exists in the Python, right? I don't know if we have something that's called weather intent in the Python. We don't. Do we have anything called weather in the Python part of the code base? We don't. Do we have anything called branching? We do have a test async, test flow basic, test designed for conditional branching, test branching positive. And so here we can see that there's like a very simple branching workflow. Is there like an intent classifier, something like that? Main intent classifier. Is there something like that? This is weird. I thought there was like something called classification. That's weird. I could have sworn that there was something there that was like this, but who cares? Who knows at the end of the day? All right, let's go back to Ampcode. I'm just going to say, oh, look, I want a really elegant way of specifying a branching workflow, like Go, write a new design in, it's right, like I'm already creating new design documents. And at this point, I kind of want to mark this like other one, like, oh yeah, this is deprecated now. Of the Go Flow Agent Framework Architecture.md. And so we're going to see what happens, right? Like this is Sonnet 4 now. We're going to look at the thinking traces, which I don't like the UI here because I do want to see them in real time. I kind of want to have them like nicely presented so I can read them. So the Python design is much cleaner. So the current was separate worker interfaces. So I think this is pretty good because maintains the event-driven benefits, but simplifies the interfaces. And so that's what I'm going to go into. And today I designed a couple of APIs, like I added MCP embeddable support to my MCP framework, which means you can just like pull it into any kind of Go program and quickly expose it as a MCP server. Because the thing I really like about Go is having like self-contained binaries, which makes it really nice. And if you build something as a self-contained binary and you immediately have like an MCP verb in there, it means that your binary can just be like used as an MCP server. So we're going to be playing with that, right? Like we're going to add MCP support to this, not as a client, but to expose agents as a server, and then we'll see if we can like wrap this up with an MCP client, but that's like for later on, right? So let's see what we get. Let's see what we got in this new document. So if we go in here and we read it like this, the node interface, prep, execute, post, and params, max retries, retry wait. So I'm trying to think of how this would be implementable into something that is event-driven, actually. Because imagine in the prep, we want to do a database query, and we want to signal to the prep, to the flow builder that something has happened. I think that's why I had workers. I think that's why I had workers. So I don't think this is all that great. I think I actually forgot, how this is supposed to work. So let me go back to the branch flow. Let me see how the handlers are going to be used. And let me see if we have main.go. We have a single main.go, right? And it sets up the basic flow. And then the node worker is actually the thing that connects this to the event-driven part. So if I look at, where are we here? We have a question worker, which is under event. So this is kind of like a mess in here. And then in the main part, we create the nodes, we create the answers. And so how does the flow work? I think we have a runner. The flow is purely declarative, I think. And then the runner registers the node workers, and the question node worker, I'm curious about how this relates to the nodes themselves. How does it link the nodes to the workers? Because this returns a simple node worker. And the node worker has the name. So maybe the worker is what allows us to return create the node. Right? Because the node worker is an interface here that returns the type of the node this worker handles. And maybe the node worker can have an interface that creates the node itself. Because the node definition here is going to be that part. And a node has an ID, a type, a name, and a param. I'm confused about like how to best deal with the fact that a worker has to be listening to an event publisher and is parameterized by something, and then also returns like a node that can be registered to a flow. So I think instead of making it possible to, so I don't know if anybody's like following me in what I'm doing here. But I'm basically trying to connect two things that are very different from the Python part. The Python part, you can say a node has a prep and an exec and a store, but I can't, right? I can say, oh, start your prep, and then getting an event back that's called like prep completed. And only then can the flow say, well, then I'm going to send a exec requested, right? And then the worker says like, okay, I've got an exec requested. I'm going to continue working on that and send you an exec completed. And so that's a worker, right? Like it can do this over and over and over for different different execution runs of the same flow. But what bugs me is that we do have the node type here and we have params, when on the other hand, we do have a question worker over there that is where is it here? What is your question? And then the thing around here, what would you like to know about? I don't know how these params relate. Are these even used? Is this method used, the params? It's used in generic flow worker, and it sends an exec requested on the node type. So I think we can merge the node into the node worker interface and just call that the node, right? The node worker interface is something that handles a prep request, that handles an exec request, that handles a post requested, and handles an exec failed. So those are the events that it needs to handle to do its job. And then the flow builder is just there is just like a declarative data structure that says how to route things to the next part. So maybe this could be used to create a new node, right? Like maybe the node worker interface has a get a node out of it part. I wonder about this, like params, like how do we parameterize different nodes for the same worker? I think this is I think I have an idea. And as you can tell, this is the hard part now that is left when you do this kind of crazy agent coding, is like, I do need to have a very clear idea of the API that I want. And this is a hard API to design. So what I'm going to say here is that this is a go port of all of this. Write a new design. We should keep the node worker as the core interface because it exposes the actual event-driven functionality. However, I think we should move new node to actually be part of the node worker interface. Maybe so that we don't need to keep the node types synchronized. So we could do flow dot add node worker new node params, something like that. Suggest a couple of different designs that go into that direction. Do I need to do this in Ampcode? Not really. I could do this in a variety of different systems. Mostly it's about me thinking, right, at this point. And I can look at the output and see what all these things are. So here we would create these different weather workers, and then we would say, okay, let's configure all of this. Merge node worker and node into a single interface where workers are nodes. So I don't think that's necessarily what I want. I think the same worker should be able to handle a whole set of different nodes that are of the same type. Build a pattern on node worker. No, I don't think that makes much sense. Registry based with smart resolution. So I thought about that. I think that might not be the worst idea, but I think that's actually maybe the worst idea. Recommended design, hybrid approach. I don't think this is useful. I think if we go to the core node worker, I think we should just add like a get node, new node, params node, and I wonder what the flow worker really needs to do. But I think that might be enough to get this whole thing going. And then maybe we'll add this. I actually just added the new create node. Is that what I called it? New node method to the node worker in interfaces.go. Get rid of the current way of doing things and use that instead. Also introduce a type, a type alias for params, right? And then one thing I wonder is like who does implement node worker is we have, so exporting core interfaces, like kind of interesting. We do have, say, new simple node, which I think is not configured with parameters. So I think this is all good. Also introduce a type alias for params. I think we can go and basically now bank on the fact that we have everything we kind of need in our context window, which is already pretty full, right? That to go ahead. And I don't know if the Sonnet 4 window is bigger. It doesn't seem to have registered in Ampcode just yet. Holy shit, this is actually really big. But we'll see what we get, right? This seems broken. Yeah, this seems broken. So it's kind of experimental, right? Like I kind of modified my settings file to have Sonnet 4 in here. So maybe this wasn't like the best idea. Maybe I should turn off the thinking traces. I'm not sure. This definitely seems broken. Let me see if this has something to do with it. Or if it's just Sonnet 4, or if we just need to, if this is actually a breakage of this thing before, where I asked it to actually write a file and then it already broke over here, and now everything's kind of broken. I suspect it's the brokeny everything. Like I don't think we'll be able to salvage our way out of this one, because I think some kind of XML tag is missing. Yeah, we can see this just doesn't work. So however, what I'm going to do here is I'm actually going to create a new conversation and say we want to get rid of new node on its own, and instead, as a simplification of 07 long-term document, blah, 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 have node workers present a new node function, and that should be the only one used to create nodes to be registered to the declarative graph. Furthermore, introduce a type alias for map string interface for the params of a specific node instance. we'll see. We'll see what this does. And so what we can already tell, and which I had forgotten as well in my head, is we have a set of node workers. They're really there to receive events and process them and then send events back out. We have a flow worker, which is responsible for receiving these events from the node workers and kind of figuring out, okay, well, what's the next node I should be triggering? What's the next node I should be doing here? And they do this they can do this with like 15,000 agent runs at once, right? But however, we also have this declarative version of the node graph, which is really just like, oh, when this node returns this action in an event, then like, please trigger this other node with maybe these parameters on the transition. Or actually, I don't know if the transition can do anything. So that's where we're at, and we're going to clean these things up. So currently it's just like reading the code base. It's using its like little research agent here to do stuff, to find the relevant information. And once it has all this, and this really like fills the context window fast, it's going to introduce our type alias, which is exactly what we wanted to have. It's going to use this interface in the node. It's going to implement the new node, and then it's probably going to go over, it's re-exposing the interfaces, which is fun. Which probably isn't like re-exported. But I think now we just kind of have to wait until it finishes, and we'll look at some of our current examples and see if they work, right? Because I can tell already this like branching flow was not working before because it didn't have the code to launch the workers. We'll see now. I know the simple flow, the basic flow, which was in the main class, was working. And once we see that these three flows are kind of working with like a mock client, we will start maybe, because these things are like hard to trace, right? Because it's event driven. Either like assume that things are still like kind of readable in the console. I think what I want to do tonight is actually connect this up to have a real LLM worker node, and then basically just build like a real agent, right? So we'll see how this goes. This is actually something I could already be doing on the side if I so desired. I always am unsure how to do this with Ampcode to do directory spanning kind of work, because I have a huge, not a mono repo with all my packages. I do have like my packages in a ton of little directories, which each are their own GitHub repo. And I do have like a massive work repo, but I don't think this is like the best idea. So maybe something I'm going to do is like check out both Geppetto and the agent, the Pocket Flow, into their own work tree in a single directory where I will have a Go work and then use that to do it. And actually, I'm going to, on the same side here, I am going to just like, I want to check out this repo and code corporate headquarters Geppetto as work trees in a new directory where I will also have a simple Go work to load both. How can I do that? Don't write any files, just tell me. And first what I'm going to be doing here on the side on the right is I actually want a tool to have that, right? Like I want to have a tool that kind of allows me to register all my GitHub repos and then quickly say like, oh, I want like a work tree where I can check this and this and this out. So what I would do is it would create a workspace. I would clone this repo and this repo into the Pocket Flow, and then I would add this as a work tree. And I could do this. So interesting. All right, so what is it doing here? So it has created all of this, and now we're just going to build it, right? It's like timeout, 10 seconds, go run, flow basic, echo waiting. So we're going to see if it's able to build it, and then we'll see if it even runs it. And we can see it's like running it. It's maybe starting it all perfect. The changes are working correctly. I don't know if it's been like running though. Oh, it did complete the flow successfully. The thing that's wild is that it seems to be registering the handlers after it says that the flow finished successfully. So that's a little bit weird. There's the visualize feature. So I'm a little bit skeptical here because that's not what it would look like. But we're going to go in and then look at how it executed all of that. This didn't seem to have changed like a lot of code besides that. So anyway, we're going to use this later on as we go into implementing our LLM stuff. But first, make sure that this kind of works the way I want it to work. So if we go look into how this all works in the main part, we do have a flow completed completion handler. So this is getting run once the whole flow in the runner is finished. The runner is something that when you initialize it, it's going to create the store. It's going to create a watermill publisher and router, which is the way we do event-driven dispatch. It could be that the confusion in the logs is because of race conditions or like asynchronous behavior, but I don't think so. I think this is a little bit odd, and what we're going to do is I think this could benefit from more logging here. So that's what I'm going to do. And maybe I should just, I'm just going to say like add more zero log debug logging to the different workers when not already present to help us better trace the event-driven flow. Having these runs with a lot of logging always adds like a lot of tokens to the context window, which might or might not be good overall, but it's just like something to be aware of. And there's no real easy way to like remove it. So logging a lot is always like a two-edged sword, but it always helps a lot to kind of see what's going on, right? And then maybe there's too much logging at the end, and then that's something you can either change the levels or you can revert with an LLM as well. But basically think of code as like something like pizza dough, right? It's like you want to make a pizza, but on the way there, you just like do all your stuff and you like stretch it, you put it back into shape, and then you I think of this code thing as like a very malleable kind of substance that is also not really worth all that much compared to when you write it by hand. Obviously, you kind of want to hold on to your logging lines because it was tedious to add them, right? Like now they're just like free. Kind of free because I'm paying. I'm paying for it. So while this is running, let's go continue having a look at the main Go function. So we have a new runner with a flow completed. We initialize the runner, which I think is not starting it just yet. It sets up the handlers, the progress handler, the router, the publisher. We do then set up the basic flow, which is going to create a mock LLM client, is creating our question worker, right? I wonder if we can just like make this a little bit more elegant as well. I'm not sure. We have a new answer node worker. So obviously it's not going to be as elegant as the Python version overall. But I think this is not too bad. And then we get our node with some parameters or none. And then we have the node flow builder, which is going to push the question into the answering, register it, returns this flow. So we have this like kind of nice declarative kind of thing. And we also register the node workers, which is going to register all the node workers, which is going to register the node worker. And then this on the watermill event router is going to add a handler that's going to handle, right? Like each node has a topic, each node worker, you could say. And this is interesting. Like, does it actually even need to be responding? No, it sends back empty things. So this could be like a add handler, no publisher. I'm not sure if this is like the best way of doing this. I wonder why it added that. Because it doesn't really need to. Yeah, I'm not fully sure why it doesn't like use the add publisher no handler, right? Because there's add no publisher handler. So we could maybe simplify this as well. But to go back to Ampcode, Ampcode is adding more logging, adding event logging to the handle to the watermill router. So I'm not going to fuck with that file while this one is editing. Like that's kind of asking for disaster. So while this is running, we're going to go back to our other implementation thing here, which is, you know, maybe we could have this in a different agent running with Ampcode as well. But I first want to like kind of chat, you know, have a more halting flow where I just chat until I get like a good spec. So create a spec for a TUI that allows me to select from a list of repos configured through a config file that I can and then create one of those work tree checkouts plus go work initialization. Store in ttemp 2522, I think, 02 design work tree TUI to quickly set up workspaces.md. So we're just going to create like a spec here, and then we just take the spec over to Ampcode once we're happy with it. So that is running. I think there's nothing much else for us to gain here. We can go maybe... No, I don't think there's much to gain, and I also don't want to split my brain into even more fragments, even though if I was alone, I would probably start a third part of this. We also have this codex branch that is still out there. That is where I asked it to go over the cookbook and just like convert it. But so we'll see. Now we have more logging, right? Like we'll be able to launch it now and see the long output is like indeed the issue here. And then this is going to fill our tokens like so fucking fast. So that's always the danger of running things in here. And here I did it just because I don't know why I did it, but it's actually hard to read here. So I think this is working correctly, right? Like we can see the node workers doing work, publishing, receiving answers, and this all seems pretty good. So I'm going to commit at this point. I'm going to add ttemp, and then I'm going to say move new node to workers, and then call that, you know, just push it for now. We have a design here of a terminal UI to set up workspaces. So we're going to look quickly at it. Multi-select list, search filter functionality to quickly find repos. Sure, why not? Repository metadata display, description, last updated, current branch, I think is the better way to phrase this. Current branch. Dependency visualization, I don't care. So the thing with Sonnet 4 is that it will add way too many features that if you ask Ampcode to implement them, it will just like maybe do too much. Interactive TUI that automates the process of creating work trees. I don't want to have cloning repos. I just want creating work trees. Yeah, so target users, workspace name input with smart defaults based on selected repos. Sure, why not? Target directory selection, yes. Branch selection, deeper repo. Gonna remove this for now. Conflict detection for existing directories, sure, why not? Real-time progress display, I don't care that. Detailed logging, no. Error handling with retry options. Yeah, sure, why not? Configuration file format is we have default base paths, we have our repositories, local path, default branch. Yeah, so what is subdirectory here? Yeah, sure, why not? And then we have presets, which is pretty nice too. And then I don't think we need the settings. All right, select repositories for that. And then workspace configuration is also good. Create workspace. Cloning pocket flow is not something we want. Now we're going to say setting up pocket flow work tree. And then we're going to add here, don't replace view logs with a scrolling logs widget. I'm curious it's going to edit like ASCII art. It has trouble. I wonder if like a bigger selection is going to make it work. No. I wonder if a different model is going to work. No. All right. So we're just going to move it like this here. It's funny because the tab completion is able to do this. All right. So this worked. I don't know why the other one didn't work. Architecture, app.go screens, components, repo list search, config, workspace, Go workspace initialization, workspace creation logic. Sure, why not? Input validation. I don't even know why we would need that. I'm going to remove the utils and just leave that up to the implementation thing to do this. Configuration, Viper, Git operation, go Git, CLI framework, Cobra, that's all good. Load configuration, display repo, show preset option. I don't even know if this is like all that necessary. I'm going to keep it in there. Yeah, I don't actually, the cloning was maybe not the worst idea. No. So maybe I'm going to go here and then remove the URL part. And that's something we can add later. If I think this is useful, I can always add it later. I think the presets are pretty nice. Future enhancements. Yeah, the validation is actually pretty useful. Common issues, network issues, retry, permission errors, existing directories. I'm just going to remove this. Yeah, I think I like that. All right, so we have a nice design for this design worktree tool, which, however, I don't want to build in this Pocketflow repo directory, right? So I'm going to open a different cursor in my kind of like messy experiment repo, which is called GoGo Labs. And GoGo Labs, I had it open this morning, and we're going to actually create this file in there as well in the same kind of repo thing. So we're going to create a new file, which is called 03 work tree utility design document .md. I'm going to paste all of this stuff, and then I'm going to go into Ampcode, create a new one. I'm going to say implement 03 work tree in command apps work tree TUI. Make pkg under that directory as well. Make everything under that directory. Create everything under that subdirectory. And then we let it go. Like this is Sonnet 4, so I think it might just like go on for like an infinity. And we'll see what happens. Oh shit, there's people watching. That's like crazy. At least people clicking on it. So while this is going on, I do have high hopes for it. Like I haven't said anything about bubble tea, right? Like this is all going to be like out of the training corpus kind of charm bracelet stuff, which it always is like a gamble. So I don't have the highest hopes that this works, but you know, why not? In the meantime, we do have our base Go agent framework with event-driven stuff working. So the thing I'm curious about now is, can it run one of the more complicated parts? And can we look at that on the console and see how far we go, right? So if I run Go, main.go, then it doesn't have anything. So I think I need to go on the main Go and then just say main Go. All right, so it output like a shit ton of stuff in here. We can see our watermill logs are a different kind of logs, and this is maybe what led to this slightly more complicated way of viewing things. This is the downside with event-driven stuff. It's like impossible to basically see what's going on, right? It's just too much of a mess. It's kind of tricky to see anything. So maybe a way we can do this is we can create an observer that will listen to each node. Each node has a topic, and will then publish this over the web so that we can see a real-time scroll of it. And I do have a React framework to do all of this. That's going to be a little bit too much for tonight, and also it's not going to be very vibe codey. So what I'm going to do is I'm going to start a new Ampcode session, right? And I am maybe going to work again on a design document at first. For some reason, I like doing the design document in the cursor chat. I'm not fully sure. why. But what I'm going to say, like, I want a way to observe all the workers in a system so that I can make an elegant visualization of events as they happen and trace a certain flow execution, for example, right? The overall design of our Go event-driven system is in 07 long-term, right? And you understand why this document is called long-term. It's something I'm going to reuse over and over and over and over and over, right? So now design a elegant observer mechanism that listens to all the node workers and flow worker, and is able to print out each event in a nice format on std out for now. Store the design. Actually, since we're doing a design where it might actually go full in, store the design in ttemp 25052203 observability for the event-driven, driven Go agent framework. And I give them these long names because not only is it nice for me to see at a glance what it is, but also because LLM agents, or like coding agents, often will use find or the list of files to make decisions, and that way they already are strongly steered towards what is in this document instead of calling it like plan or design.md or something like, or PRD or whatever things you have out there, tasks.md. So it's reading the document. It's reading, like, I don't know why it's skipping like a shit ton of lines in there. It's a pretty long document, actually. So, you know, maybe it shouldn't be that long. Has a lot of code. There's a lot of examples. Probably has like a lot of slop that actually doesn't really help. So we might want to boil this down also at some point. Because this fills our context window, right? For no reason, really. But also, like, this gives, I think for the observability, this may be a good idea for it to see like a lot of examples, a lot of the stuff that we might want to observe. But as we're going on, this other agent has hopefully finished our little tool. And maybe I shouldn't have like directly started with our thing. Shit, I've like already lost all my credits. This went fast because I burned. I'm in a team now. How do I buy team credits? All right, I might just like do this whole buying credits, and we'll see. How many credits do I want? I guess we're gonna do $50 again. So we'll see. Did I get a text message? I did get a text message. And all right, we're paying some more. Because I think I burned like 3,000 credits already. Yeah, see, this is like printing out the log and just burning it. That was like maybe not the best idea. And I'm you know, honestly, like, I know this is a design decision, but it kind of pisses me off that I don't know how much a token costs per se. I mean, I guess I could look it up on the Claude documentation. I'm not sure, but like, I really wish I had like a little bit more visibility in there, because I'm like, yeah, how much did I write today? I didn't even like write too much code today, right? I did like 8,000 lines. Did that cost me like $30? Anyway, retry. All right, so that was good. So maybe that's why I should maybe do stuff more on the cursor side. All right, let's go back. Let's go back to our code. We're designing the observability framework on the same time we have like a TUI going on. And, I realized like the TUI, that was like maybe a little bit ambitious, especially with Sonnet 4. But on the other hand, I want to know how good Sonnet 4 is at Charm Bracelet, because there was like a significant improvement in doing Charm Bracelet stuff with like Sonnet 3.7, for example. So we do have a file now for our observability framework, and we're going to look at it and delete the slop, right? So this is good slop to keep. See, this like is Sonnet 4 stuff, which is like it always does a little bit too much. We might actually redo this like design stuff with a different model just so to show you. System health, visibility, and resource usage. I don't even know what that means. Non-intrusive design, minimal impact on system performance. I really don't care. Extensible architecture, easy to add new observers and output formats. I don't think this really helps. This, however, is very much intent driven, right? Like instead of saying how and why, like I only want to have the why and what. I don't want to have anything related to the how. And I don't want to have anything related to additional constraint because I want to leverage whatever is in the training corpus. And these things have been trained to output exactly that kind of slop, and they're going to output that kind of slop in code as well. So I don't need to like push it further. It's the same with this here. The system provides elegant event observation, blah, blah. This I'm just going to delete because it's too risky to like forget sentences like this. System health in real time, which is not only like something I have no idea what the system health even is supposed to be, but they can still latch on to this, especially if it's like at the beginning or at the end. So use the observer pattern to decouple monitoring from business logic. I'm going to delete that. Event driven, leverage the existing pub sub of all of this. I don't think I need any of that. Because I care much more about the observer system. So there's the node workers, the flow workers, the event router, and the pub sub system. What does this graph look like? The pub sub system has an observability layer with an observer manager. That makes no sense. So we're going to delete this entire graph. And you can see like this is what's left over of like engineering in a way, right? Like this is going off on its side, and the only thing that really would be good input of me at this point is saying like, no, this is not what I want. And that's what I'm doing here kind of, right? It's like the observer interface observes an observable event and optionally transforms it. Okay. Observable event represents any event that can be observed. Sure. Observer manager, register observer, unregister observer, notify observers, and start and stop. I don't think I need that. I also don't think I need an event tracer. Do I? I think this is like additional functionality that I don't want right now. I don't want like tracers. I want the on-flow tracer and I want a node tracer, right? And performance metrics for a node, I kind of don't care about that. And so these things have an observer. And then observable event is also a nice overload of all of this. And I think having events, observability events that are different from the actual events, I think is nice because it allows me to add things to it that wouldn't be in the core message. And then the system health event is something I'm going to delete. Tracing data structures, we're going to delete because I don't want like all these kinds of things. I don't want the node metrics or the flow status just yet either. And then the implementation of it, holy shit, this is a long file. I don't think I want any implementation of it here. And this is the problem with like Sonnet, right? It's like it'll just like go ham and just build way too much. So why is this not closing its code? block. Because I deleted this. All right, so all of this code here, I kind of want to have, because it built too much, right? Like it probably, and probably all of this works. Like probably it does like a, you know, this is not like the worst idea over here. The event tracer, we don't have spans. So I don't think we have spans in the events. I don't know where it gets the span from. So we'll leave that. I don't think we need that just now. And then we have examples with the metrics observer. We don't need either. New WebSocket observer. See, it already added it. It's kind of crazy. I didn't even ask for it. So what I think is going to be interesting here, I'm going to delete all this code, right? Like it might already all be working, but I'm still going to delete it and pay SourceGraph to do it for me. Even though it's going to be the same model and all of that, I don't expect much different to come out, but this gives us like a clean document to kind of restart if we want. So we're going to go to Ampcode, and then we're going to say implement 03 observability for the Go agent framework. And maybe what I will do is, like, while I have all of this in the context window, is create a more streamlined document explaining 07 without, but much more concisely. Store it as ttemp 250522 04 long-term concise Go Pocket Flow design architecture document.md, because that way we won't burn as many tokens every time we link the long-term thing in here, right? So I want to link something that explains the architecture of all of this in here to avoid having it like go into all kinds of source code and have to figure it out on its own, right? Like this is going to be kind of like a cached version of reasoning in a small amount of tokens so that we can save on tool calls, ultimately save on time and money as well. And also it gives us like a nice document to concisely read for us, right? So moving forward with this smaller document, let's see where our other dude is. So I'm not going to run something that's a terminal UI from Worktree, right? So we're going to go to labs, and then we're going to go to command apps Worktree TUI, and then we're going to do go run dot and fail to load configuration, no repositories configured. It's a good start. So maybe what's the format of our config file? Do we have that somewhere? Yeah, we do have that somewhere, and this is in the README, right? So if we go look at the README here, we do have an example file here. We're going to fill it out. All right, so let's create an empty repo. And, you know, of course, the TUI should be able to create the config file and initialize it. But for now, I'm just going to do it by hand. So config worktree TUI, config worktree TUI, config YAML. I'm going to paste this. And default base path, code workspaces, sounds good. We're going to call it code Vazen workspaces. My project, I'm going to call this Geppetto. I'm going to sell the Geppetto LLM framework. It's so weird to work without a tab complete. Corporate headquarters, Geppetto, default branch main, tag LLM, shared directory. We're going to call this glazed, which is another standard thing of mine. the URL, which we kind of don't need. Why did it keep that shit? I said no URLs, but call this glazed, and then monorepo tool. We're going to have labs, and then we're going to have the agent labs. Go labs. Go labs. And it's not a library. I don't know if the tags are going to be all that useful. And then we're going to have the agent that we're working on, Pocket Flow. So that's going to be in a different directory, Pocket Flow, and this one is in others, Pocket Flow. Default branch, main. All right, let's leave it like that. And then complete development environment. So this is Go Pocket Flow, and description Go Pocket Flow development. And this is actually going to have Geppetto, glazed, and Pocket Flow. So if we launch this again, repository Geppetto must have either local path or URL, but it has local path. Config validation failed. All right, well, that's a good start. So my config is, however, all right. Let's go back to our shorter design document. So if we look at the shorter design document, we can get rid of this fucking diagram because it really doesn't help anybody. We do have, however, a good description of what these different things are. No, so this is like data structure used to create agent graphs. Yep, execute nodes and flows via message handling, topics, route messages to appropriate handlers. Each node has a topic, so has the flow worker. So each node worker has a topic, right? That's kind of an important phrasing to use. Then we have the different interfaces here. This is kind of like a little bit too minimal, but like who cares? We're gonna add this and this in here just to signal that there's more to be seen there. It has a bunch of type. This is great. Having like a list of topics is great. Having a way of determining this. So this is not correct, right? Because we had the node workers change. This is because the document is not actually up to date. So update the 04 long-term with the slightly updated API where new node is on the worker and where the flow builder uses on action next node as a syntax. Because that is actually important. Otherwise, if you have a document where this is wrong, it will like always kind of be confused between if it found the right implementation or not, and then it will like start linting things and will just like confuse itself quite a bit. So spending a lot of care on these like high level long-term documents is really important. And I made the mistake of not double checking that it was like updated correctly. I don't think we really need this down here though. I'm going to wait until it updates that stuff. So going back, did it change that? The issue is subtle. The expand path is treating code incorrectly. When we have code after removing, we get /code, which is joined with the home directory incorrectly. The path expansion is happening after validation. The validation is checking the unexpanded path, which doesn't exist yet because the tilde hasn't been expanded. All right, so that's interesting. So that means if I try it again, it will work. Must have either local path or this. No, so this doesn't seem to work. But Geppetto has the local path entry. Add some logging with 0 log debug and set default debug level to help investigate. Right, so we're going to leverage the fact that we have logging to help the model figure out what it did wrong, which is something that I should maybe hard code into my technique. So did this update the examples down here? So it does the workers, it creates the nodes, then it creates the graph. So this all looks good. And then I'm going to say also update the long-term document, right? To make sure everything is up to date. And I'm wondering, I'm already at like plus 2,000 lines in this conversation here. So it doesn't warn me yet. Also, it's just documents, so we don't care too much about hallucinations per se. I hope that there's not too many. Yeah, man, how fast is this going? Team credits. Where do I see the team credits? So this burned 150 credits. I don't know what we did, actually. We didn't do anything, right? We just like worked on this guy. Shit, that stuff is expensive. Maybe I should just join SourceGraph. But then I won't be able to work on my open source probably. All right. Well, I guess we have to kind of wait. Actually, we don't, because we have the short term. We have the short document now. C04 long term for the system overview, right? So now we're going to implement our observability. Implement a std out observer first, because we want to do a WebSocket 1 after that. Why is it exploring the Go? Oh, whatever. Oh. So every time I start coding, all my tiredness disappears, and it's a problem because I'm actually sick and I should be resting. But today was just like way too exciting of a day because I have some killer ideas that actually work, and I don't want to. I mean, they're really good, and I know it's horrible when someone teases you like that because it's like so common in the space. But it is around MCP, and I finally was able to nail why I am so confused by why it's so not good. So by that, I'm not saying MCP per se is not good. It's like, it's just LLMs can do so much more than, generating a ton of token, then calling out to something, getting tokens back that goes straight into the context window, then having to process all of that, and just basically being a really fucking slow CPU, right? It's a magical CPU. It can do like all kinds of shit, but it's really fucking slow and it's really expensive, and they're actually so good at writing code. Why isn't it a CPU that can like basically program itself and then just, right? Like, if I do something that queries a database once, I don't need to, every time I want to query it again, to rerun the same MCP tool to get the same huge amount of data back, to then have to, right? Like if I want to say, I have a database and I go in and the LLM doesn't know anything about the database, right? And I say like, oh, well, give me all the users and like the last time they logged in. So the LLM is going to go in. It's going to be, actually, let me see if I can quickly show you that. So we're going to go into MCP UI. We're going to go to Claude, and then I think I have the SQLite server enabled now. So we're going to launch Claude Desktop. Why is it still running? All right, Claude Desktop, I love you. Which tools do you have enabled? So we are going to disable the extraction tool. I should have done that from my TUI. But so now what I have is I have a SQLite tool, which literally has just like open in SQLite as a tool, right? And the first thing I'm going to do is like open temp users DB and then create a whole company capabilities user schema and fill it with test data. Keep it fairly minimal at like 3-4 tables because it's Sonnet 4 and it's like smoking crack and it's just like doing crazy stuff. So it's going to create this database with the open. And so hopefully that works. MCP server bridge has disconnected. We could not record the tool result. Okay, that's cool. Is it because it doesn't have access to /temp? No, it was created. All right, cool. So it's creating a table and then it's creating like capabilities and it's creating like all kinds of stuff. So what I was going back to why I think MCP tools are limited, right? It's like, if I open this database later on, it's like, oh, give me all the admin users. It's going to go in, it's going to like look at the database schema and it's going to look at the users table and it's going to look at the capabilities table. And it's going to say like, well, it seems that I have an admin's capability and I have this. And so it's going to do that. And if I open a new session, I have to do all this shit again, right? Because the LLM doesn't remember what it did in the previous conversation. So either I could attach like a document that says like, look, this is the database schema, but then it's still going to output like a lot of tokens of being like, select blah, blah, blah from users, join, whatever. And maybe it will get it wrong. So we'll try again and we'll do like 5 queries. And basically I'm waiting for like 4 minutes to just get which users are admins. It's amazing because I haven't written any code, right? I just say like which users are admin, but it's also pretty inefficient, right? So for example, what I can do is like make a table of all users and their capabilities. And because it has created all the tables here, it like kind of already knows the schema and it's going to generate like a nice query to do so. And it's going to get all of that, right? Like it's doing all its join, but this is already like a ton of tokens, right? And then it's outputting a ton of other tokens, which might not even be the ones I need. But the LLM doesn't know that, right? It doesn't really know about these things. And so, oh, I didn't do like security capabilities, but so what I want to do is like add a auth capabilities layer as well. Who is admin, who has which roles, enums, etc. Right? So basically, and every time I want to see this, it's also going to recreate a UI that not only is going to be like different every time, but is also going to be like slow to generate, even though the information is kind of everything about this is deterministic, right? It's like the magic of the LLM was to understand create the query and then create some kind of UI that is pleasant to look at. And of course, this flexibility is huge because now I can go in and I can say like, well, make them grouped by capability, right? So while this is running, I'm not going to interrupt it. But basically, with my MCP tool calls, right? Like now we can integrate them as streaming. They're probably less expensive, but like look at this huge amount of, well, actually this is cheating because it's like doing a lot of stuff here. And then also Sonnet is just like likes doing a ton of stuff. I'm going to start a new conversation and you'll see what I mean, right? So now we have like admin, we have the different roles. And so now I'm going to open a completely new conversation. I'm just going to say like, oh, like give me all the admin users out of temp users DB, right? So if I do that, oh, come on. If I do a new chat and I say like, give me all the admin users in temp users DB, it's going to look at the schema. It's going to like look at the tables. It's going to open it. It's going to do all its kind of like stuff. And right, it's doing like 1, 2, 3 calls. It's like burning some tokens because all of these tokens that come out are going to be shown again. It's thinking about it, and it takes a lot of time. Like I'm still like 20 seconds later, I still don't have my admin users when this is actually something I might query every day, right? So this is like a fun exploratory things, but LLM could be doing so much more than just that, right? It's like, oh, this is like a pretty cool query. So here comes the magic thing. Is like the only tool I have here is SQLite, right? Like the cool thing would be now to create a tool like, oh, give me admin users, right? Because it's a tool I might reuse often, or it's like called like get users, and maybe it has an argument that's called role, and then as a role you pass admin, or you have like a flag that's called admin is equal to true, which is great. But like, how do I create this tool? I have to go to an MCP server, like write my own MCP server, which is pretty simple, but I have to do that, and I have to like reload Claude. I have to do all of these things. But what about create a view to quickly get admin users, right? So what I'm doing here, if you look back at this paper that's called Voyager, I'm really giving all my alpha away here. I shouldn't. Before I make like an article. Someone's going to steal it and it's going to like become crazy famous. This paper, but anyway, the paper's been out for forever, but also this is something I arrived to like independently. It's just like recently someone pointed me towards this paper. This thing writes code for actions, right? And so it plays Minecraft, and then when it encounters a zombie, after that, it creates like a tool that's called fight zombies. And so in a way, this is kind of what I'm doing here is like I'm creating a tool, a SQL view that's called like give admin users, right? And so now you can just do that, which is 4 tokens or like 5 tokens or like 7, I don't know, 10 tokens. It's much, much shorter than whatever queries it did here, which was this, right? And then it ran it again and did this, right? So now I kind of have stored my view in here to it. Maybe it even created like active admin users and another admin user, right? So what I can do is if I start a new chat, I can do this, and it's like open temp. So I do have this like little and get the views, then make a table with the admin users, right? And so make a table is actually bad prompt engineering. Hold on. Make a markdown table. This still has to read the schema, right? It still has to open it. So this is something I could put into my system prompt, say like, oh, make a list of all the views that we have and their schema as like tool descriptions, basically. But it allows me to create like tools as I need them, right? And now the tool call is like super fast to generate, right? Like you saw how much faster this was compared to the first one, even though it still had to do all of this stuff, right? And you can, if you now expand it, like I only have SQL here to do it, but if you expand it to say like writing JavaScript, it's like, why do I need more than a tool call out from the model? Do I even need a tool that's called like eval JavaScript? Or basically write a JavaScript file and then evaluate it, and then as we go along, and I say like, well, I want a view to see the admin users, it's going to write JavaScript to create like the JavaScript, like this view of Markdown, right? It's because I can do this, right? Like create a Node.js script that queries the view and outputs exactly that populated Markdown. At this point, it's all deterministic. I don't need to like every time I want to like query my users or someone else queries the users, I don't need to rerun these tool calls. I can kind of say like, look, like this is something someone did before. And instead of like exposing it at its own like little MCP server, and then you have like 15,000 tool calls in your context window, and the tool calling training gets confused, you actually just say like, look, I have a bunch of programs and a bunch of like UIs. Like people can just like, if they want to see this kind of stuff, they can go straight to a web view. But however, the web view was only created as a side effect of this first conversation I had with the model, right? Like, am I programming here? Like, I kind of am. But also like, where's this file? Oh, it's there. So, I mean, I don't know if this works. I'm not a JavaScript person. But how do I run this? Let me close all of this garbage. How do I run this? npm install SQLite 3. Oh, I already had that. Node tempdb.js. Cannot find module SQLite 3. Come on. Does someone know how Node works? Oh, because it does like which node, which npm. It's the same, right? Does it require? Is that how it works? Yeah, so why is it not able to run this guy? Like fucking Node, just like one day I'll learn how to do it. Let me figure this out though. Like, why does this throw this error after installing SQLite 3? I use NVM, so actually it might just like which node, which npm install SQLite 3. I'm gonna just like paste all of this. But I hope you get the idea, like creating functions as you go. Now suddenly, if Claude Desktop, for example, had this built in, right, like a way of saving tools and also making, like I can create artifacts, but these artifacts are not able to actually interact with tools as I call them, right? Because even though I have an LLM in the way, like in an LLM, I could, have the UI and the only handler is like, oh, like make a new inference with the click the button XYZ on there. But also it could also already like wire a REST API to say like, well, this is the view for admin users we created, and then this is a UI view that goes to myself, but at least uses this tool that I just created. So I have a design that makes this pretty easy to implement. The issue is that you install SQLite in your home directory, but your script is located in temp, looks for modules related relative to the script location. Okay. All right, right. So this was the thing, is like, it was really slow to output this from an LLM, and in the same amount of time, I can basically output the JavaScript and then run the JavaScript, and it would be like just as fast. It might even be faster because I might only have to output the tokens for one line. Imagine if I had like 200 admin users, like it might not even fit into the context window, but the JavaScript script certainly does. And then now I don't even need an LLM anymore, right? It's like, because if I do this, like add, I don't know, 150, add 15 new users, some admin, some not, this is going to take me a shit ton of time again. But I could also make like, make a script that inserts like 15,000 users. And that would be faster, right? Because now it's querying the schema again, and it's like doing all of these different things because I can't insert in the view, I guess. But I hope you get the idea. Is like I don't think MCP was like a good decision, because now everybody's like building tool calls and every time I have to do these tool calls again and again and again and again, and they don't even get better. Like every time I have to do something that requires 4 tool calls, I'll have to do 4 tool calls until I build my own MCP that does the 4 tool calls, right? Like there's not even a way of saying like, yo, bro, instead of like calling these 4 things one after the other, please like just make it an alias and then call this fucking alias. There's just no way of doing it. And it's like, I think it's leaving like a shit ton of crazy stuff on the table, right? Like, so now we have new admins, new managers, like look in the time it even outputs this, I already have them here, right? it's like before it even was able to tell me what it created, I could already look at it. And now it's running the node script even like by itself, which is like, sure, why not? Like, I don't even know what it's doing here, but I hope you get the idea. This was like kind of a tangent. And also I said at 9 p.m. I was going to stop. I have this weird thing here where it's like runner with observability. Where is it even open is like, I don't know. And why did it get modified? I don't know either. I had this happen like multiple times, and you were seeing like, I wasn't even looking at this stuff. So anyway, going back to our event go thing, and my brain's good at doing these jumps of having 4 things cooking on the fire. That's definitely the issue with these agents things, right? Like I have this little terminal UI dude. See, I have another one here. It's like, I don't know where these things come from. They like say they've been modified, obviously, but I don't know why they want to resave it. And that might be because I have auto format on, but I think I disabled it. So we'll see. So now it did create like a bunch of logging stuff. It failed to apply this. Oh yeah. So this is there some auto formatting going on? No, there's not. Like, I don't know what's going on with these things. I also don't know why it opened loader, why it opened in the IDE. So anyway, it's asking us to rerun this and see if we do have an issue with the validation here. Repository has neither local path nor URL, but it certainly does have expanded home code workspaces, original, processing repository, local path. So why is it not able to parse these local paths? Because they're certainly there. Is it because loader.go get repository by name, repo local path omit empty? That is so weird. That is so weird. Still not. Print out the YAML and parse structure. Also add caller to 0 log. So I'm not sure what's going on here, because the local path certainly is set. It seems to be loading like the right repo. It parsing the repositories. Is it because it's trying to load it with Viper? No, because like is able to find a name, but not the URL. And now it's again failing to like apply changes to loader. Very weird. Very weird, this stuff. Anyway, we had this cooking, and then we had the GoGo agent with an observability tool, which I hope is going to, if we go to the observability demo, what is that? So it complains about the main. So we're going to create a new folder, observability, and we're going to runner with observability is another one. We do have a little bit too much here in examples, huh? Actually, what it's going to do is like, I don't even need to do it by hand. I'm going to tell the Ampcode, move the to runner with observability demo into separate subdirectories since they are both in package main. All right, so here it's going to show me the parse config. So I'm curious what it will say here. The raw Viper config. Geppetto local path. Look at that. It has the local path. Parsed config. Repositories. Geppetto glazed pocket flow. Repositories. Default branch. Description. Geppetto. Framework local path. Name Geppetto subdirectory tags. Why is that gone? So that's something with Viper is like, just use the raw config then. Right? That is I don't like Viper. I don't know why I'm using it, but all right. So this, I knew it was going to do, use the shell to do it and not like recreate the file. So that's not wasting too many tokens. But it's also, it will know that the path has changed and hopefully remember it the next time. We use that. So I'm not going to run this here. Shit, it did. But now it's hopefully, so sadly I did. Is that in here, the Ampcode CD? I'm going to remove this CD. Pocket flow, move. I don't care about all of these things. Yeah. Why is it cursor user? What is open in this repository? Amp. Also modified in workspace. And yeah, so all right. All right, so the observer seems to work, right? Like that's nice. So if we do go run examples, what's in examples? Wait, where is this? It's in event examples. All right, well that's a shitty path. All right, so this is the runner with the observability. It started a question processor, published to node completed, published to node LLM answer, node question completed with action. Yeah, so this is nice to look at, right? Is this actually a true execution is the other questions that I have. Runner with observability. Runner with observability main. So it has an observability manager. It like lists the observers. And then test flow execution with the observability publisher. It starts the, it just sends like the raw messages out. So that's cool, right? And then we had another example, which I think was called observability main.go, observability demo. Because I didn't see like a lot of logging, even though we added a shit ton of logging to the other part of the framework. And I think this again is not using like observability, it's just using raw messages. So what I'm going to ask for now is like create a so add observability as a configurable flag to main.go, which is our main go, so that we can trace, say, basic flow, etc. We'll see what that does, and maybe we should git commit at some point. We're already at 2,000 lines of code here. Did that fix it? So let's see. Repository Geppetto must have either local path or URL. Jesus fucking Christ. No, so it didn't understand what we wanted to do. Don't use the Viper version of the config. Instead, use Viper only to get the path, then load the YAML by yourself. Otherwise, we use the additional sub-entries. I don't know. This is, yeah, that's where agents fail, right? It looks like it's able to load it from the config, but in this case, it's not. The reason is probably pretty subtle, or is like due to Viper. I could maybe have it ask it to do a web search, which Ampcode I think kind of does now, but I'm not sure. That's where I would potentially go to O3 if I wanted to stay in the, like, I'm not going to look at the details mode. But also, if I looked at the details as a real developer, is like where I would unblock it and then, you know, keep that as a pattern that I can reuse later on to avoid running into that same issue. So what is it changing here in the main.go? Oh, it's adding an observability publisher. But I don't think it needs to have that as passing it as an argument, right? Because the runner... So what does it do with the observable publisher here? Because it makes an observable publisher. So that's maybe not like the best way of doing this. Yeah. So this is not good. This is not how it should do it, right? This is like the wrong design. This is actually not the right design for the observer. And I wonder if the issue is that I missed that in the observability thing and that it had the word publisher in here. No, it didn't. The observers should just be subscribers subscribing to the topics relevant to them, not intercepting messages as pseudo publishers. So I'm going to still commit as a Git because everything compiles and that's nice when it does. But this is wrong. So still, I'm going to be like git sparkles add observability. And now I'm going to correct it. Still in the same, we're still at 40% tokens, so that's maybe not too bad. I showed the Claude code stuff that I wanted to show. And we're getting on to 9 p.m., so I'm going to wrap it up soon. But it would be cool to have the basic flow with a really nice observer and work from there. So we'll see how it's going to change all of this, right? I don't think it needs that. Like, I don't think it understands really how this is done. I don't think it knows that this is Watermill. So I'm going to stop it. I'm actually going to go... actually, I can't revert here, right? So we're going to do it. It was good that I git committed, actually. Going to see how that works. So it did change this. Observe observable events, because this is still good. Like, I don't think it needs to I mean, get subscribe topics is nice. Handle message topic message byte is maybe nice as well. Let's see where it goes. Let's give it a chance. And then in the meantime, is this guy getting unstuck? Undefined YAML in loader.go. I kind of want YAML v3 to be honest. Let's see. Local path for repository pocket flow does not exist. Code others pocket flow. It doesn't exist. Code others LLMs pocket flow. Okay, so that's a lot of progress. Where's Pocket Flow? So it's here and then LLMs. So go run dot. This is promising, huh? And then I can check mark them. So I want to have Geppetto, Pocket Flow, and then I want, like, if I do search, I can do Geppetto Labs, and I can do, so the problem is I'm in this, so to escape the search, if I do escape, so this is the usual issue with the charm bracelet stuff, is that it doesn't know how to bubble up the keyboard events, and so it like sends them to the wrong space. But now I can probably do continue, and then I can't create that, and enter create. This is pretty crazy. It seems to be stuck though, because it shouldn't take that long. So I'm not sure what's going on here. But that's maybe something we can look at next time. All right, so this is pretty cool, but I'm going to create a to-do because this is, so creation gets stuck at worktree checkout time, make a CLI version to better debug, handle escaping from the search field. Overall, I'm actually really impressed by this. This is kind of wild. I'm gonna remove the worktree TUI. Yeah, this is wild. I've never seen it get that far, and you can see it gets stuck on like the dumbest shit, right? Just that it's not able to load the YAML file is like what we actually spent the most time on. It's like none of the cool like TUI stuff is like fucking load the YAML. So that's something to be aware of as an engineer, is like you will often either have to do this like really deep thinking of coming up with the right patterns, or you will stuck with like nonsense like this. So I don't know what that means for the future of our profession. In a way, it's good to see that Sonnet 4 just like doesn't still get stuck in like stuff like that. But it's kind of wild, like seeing everything I've built today is first pass at a worktree TUI, and I kind of should put this into like a bigger list of topics I can do on screen. So now it's going into Watermill. It's adding the subscribe method. I'm not sure what this all means. And that's probably something we'll look at next time, right? So this was in Pocket Flow, and then here as well, I'm going to put in a to-do. And then the to-do here is going to be continue making sure that the observer is not a publisher proxy, but is just registering as subscriber. Add a WebSocket observer output with streaming events, and then make sure the framework actually works. Then use worktree TUI to check out a workspace with Geppetto, and Pocket Flow add a real tool calling LLM node. Add nodes to extract structured data from LLM calls, etc. So we're going to add this, going to wait until our Ampcode run here continues. It's going to be, see, I wish I could like, it's not able to recognize that this is a command. So it will just like cd go. Okay, well, I'll allow everything that happens in the Go directory if I do this. So, and then I'm not going to do this. So we're going to go into the Go run -flow basic observability. And I guess we did get some observability, right? This is pretty fucking sweet. I kind of love it. It's like, it's really cool. Really, really cool. Observability verbose. And now we do get like a ton of observability here. Node completed. Yeah, this is nice, man. I didn't expect it to get that far. So git check in rewrote observability to work as a subscriber. We'll have to look at the actual implementation, by the way, to make sure that it's not like completely brain broken. So make sure that the actual implementation is not brain broken. What I'm going to do here is like write up how the observability works in a document here, which is, or actually update 03 observability with all you changed, implement it so that the next developer has the full context to move on. What we're going to do actually, because now I wasn't expecting it to work like right off the bat. Kudos to Sonnet 4, I guess. Now I want to get the WebSocket going because I know the WebSocket is going to be one shot. Actually, I have other ideas here, which is make a Redis version of the examples. Turn the... Nah, I don't know. See, it has Observability Manager. It did, like, it's funny because it created it in a totally different environment on the cursor side, right? Like when I did the design, I deleted it from the design and then just added it back again. And I don't think an observer manager makes all that much sense. But see, I'm pretty skeptical about the start stop in here. We'll see what it does, and maybe I'm wrong, right? Like, because more and more these models actually know better than I do. Which I've made my peace with. Like, they're better designers, they're better implementers, and they still don't know how to debug a YAML file. So it's this weird peaks and valleys kind of stuff. I don't think they'll ever really understand how to fix a YAML file, right? But also they just don't know what to build, right? In a way, right? Like they know what to build in a certain context, but that doesn't, for example, I think, explain why, why I seem to be able to one-shot bigger stuff than others, for example, is just like, right, like people are going to look at this and they're going to be like, yeah, but this is like just a new feature. I'm like, no, man, I just like expanded my framework to have new functionality. And it so happens that my system has been designed in a way that adding functionality just doesn't require modifying anything else. And that's why things work so well with LLMs for me, is that I've architected the system such as not requiring much modifications to add new functionality, and thus LLMs being good at greenfield, right? Like they hate modifying existing code that has complex relationships. That's why I can like one-shot bigger things like this one here, right? It's like add a HTTP plus WebSocket observability, flow management UI that allows me to start a flow, restart a flow, and see the events streaming in real time, allow me to select from a set of flows as well, add a node that delays things too, so things don't go too fast. And then I'm going to say C04 long-term concise and 03 observability, look at the existing demo in main.go. And use HTML and Go and minimal JS and bootstrap CSS. Because I want this to be like completely framework free, right? I'm pretty sure, so this is probably going to run quite a bit, but I'm actually curious enough to see if I can one-shot it, and I have a feeling that I can one-shot it. And as you can tell, I leave so much to the model, right? Like I haven't described anything about the UI that I want. I've literally described my intent, and all the rest I leave to the LLM because I only care about my intent, right? Like I don't care if this is going to be a vertical or a horizontal layout. I might care when I see it, but for now I don't care. I don't want to spend time thinking about it. The only thing that I want is like be able to start a flow, have events go by, not too fast. And I know that HTML and Go and minimal JS and Bootstrap CSS is just out of my experience to know that it doesn't start like doing React with Tailwind or whatever. Because even though React and Tailwind, if I were to do it in the longer term, and I will, is a more robust solution because it is a solution that allows me to add new features without touching existing code, if that makes sense. While if I do a Go plus HTML plus JS plus little thing, then there's a good chance as I want to add more features, I will have to modify my existing JS, and that's like a recipe for disaster. So really, this thing that I'm only like greenfielding new stuff is actually true, except I'm greenfielding on top of like a lot of layers already, and they're designed in such a way that like what I add is literally just adding things, and I have the right interfaces in place that are both like fairly small and elegant, but also at the same time allow me to build these things by just adding code, not removing code, not modifying code. And I'll remove code when I realize like, oh, my core abstraction is different. But at that point, suddenly LLMs can do well as well because the translation, the refactoring of the current consistent setup to a new API is going to be very robotic. And there's a good chance that they are able to transform something even pretty complex like an event-driven system to, say, a different set of things, because I will break things down such that each transformation step is pretty much on Rails. And at that point, sure, I'll have like a lot of modified files. And also that's going to be more complicated engineering, right? But here you can say like, I don't need to specify much of the architecture. Of course, I do have my documents that explain things, but those are like kind of cast in stone. I don't need to think about them. To me, they're just like little bookmarks that I have in my head where I'm like, if I want to do anything with this, I need to link this document maybe. Because I don't want the model to potentially not find it, right? Like often it will find that document, especially if it's like in a prominent place. But I also don't want, like, it's just faster for me to say like, look, you need this, you need this, you need this. The problem is that often I forget where these documents are, and either I recreate them or I have to ask a model to find them. But that's something I want to build a tool for as well, right? So now it's built like a delay no worker. I saw it has like all this like web server over here. It has like, I don't know what this shit is. These are the handlers. And then it uses templates. Did I see this? Template parsed execute. And then, oh shit, it has everything in a single file. That is wild. I should have told it to split it out. But anyway, I need to fix the return statement. I hope it's not like going to completely burn itself, but I don't think it does. Gorilla WebSocket, sure. Run once. I don't know why it doesn't know how to do go mod tidy. I should maybe put that into my agent MD. And then I like it when it does go build and it doesn't do go run. Man, UTF-8. Yeah. This is where things break down, right? Like extract the JS and the HTML to separate files to avoid these issues. That's why I should have told it to use like the templating language, which is what I usually do. That'll teach me. I was trying to be cute here. I was like, yeah, I'm gonna be cute. I'm just gonna say HTML and JS, but that's where models go wrong, right? Like it's totally possible that because of a fucking backtick, we lose like most of our session, most of our tokens just go onto like something as minor as not knowing what Go strings look like. So knowing these things is really important, right? Because this could be literally 80% of our development time could be like fixing backticks. And I've certainly spent afternoons where all I was fixing was backticks and then realized like, no, next time you should just undo everything and just start from scratch, regenerate. Like your HTML will look completely different, but who cares? And then you'll have it done well. Those are things you learn doing this kind of stuff. I don't have anything in parallel running, right? So good. Oh, this was my little MCP design thing that I was talking about before. I hope it's going to slap AF. I'm pretty sure it will. There's no reason it doesn't work. Because as I was building my Blender MCP where I'm sending Python and basically using the only MCP tool I use is execute Python, that made it clear of how well that works. That was also that was always my plan to do this, but also I had read the Voyager paper not long ago. I've been thinking a lot about tool calling for forever at work, and even before tool calling even was a thing, I was doing this like YAML DSL inside LLM responses. So that was like GPT-3 times, and those were kind of like tool calls. They were like also creating these like custom APIs for certain tasks and then filling them further with code itself, because these templates that I would use would have like JS or YAML inside them, or then an experiment, which is kind of okay. Like newer models are surprisingly good at handling it, but like a YAML templating language called Mrichen. But all of these things have been like circulating in my brain for quite a while. See how long it takes to just like fucking remove a string from a file. That is wild to me that this is, right? Like that's where LLMs are building. And then I will have like 3 copies of this file in my context window, even though I deleted most of it. Even though I deleted most of it, it's actually taking like the whole context window. I wonder why it jumped back actually. Are they doing something clever? Let me completely rewrite the server Go file. Like, look at that. Look at this craziness. This is where LLMs fail us. Look at that. And now I'm going to have like the file 5 times in my context window, right? It's like 1 time over here with the index HTML with everything. Then I have it twice because I have the CSS and the HTML and the JavaScript separately. And then I have it failed because it's not able to do the before after replace. And then I will have it like a 5th time because this time it's writing it clean. Like it's ridiculous. It's completely ridiculous that this is where we're wasting our CPU or GPU power, right? And then it has to recreate something from scratch instead of doing what ultimately is some pretty funny, simple string moving, right? Like this would probably have been faster to do by hand. And however, the LLM would still have had to reload it because I don't have any way of editing the conversation that I'm having here, right? Like, because everything from here all the way up to fucking over there, right? Like everything all the way from here to the first file, which is literally like 80% of my conversation. I could just like literally say, well, I guess you actually generated these 3 files instead of like tediously recreating it here. So, right, like I'm also giving it a chance to like kind of finish its job here, but I could actually just start a new chat, right? Because the inference is running, I think. I don't know if it's like restarting stuff here when it does that. Right, but like completely ridiculous. I think now there's a good chance that it's like has the window is too big and it's starting to like self-destruct, which is kind of what it feels like, to be honest. I don't know how much to expect of Claude Sonnet 4 at this in terms of stability of the context window, but I think we're at like around 60%, 70%, 60% now. 70%, 70,000 tokens. That's still okay, I would say, with Sonnet 3.5, 3.7, sorry, but it's starting to get into like directory where it can do a little bit weird stuff. So let's start go run -web. And so it started at port 8080, and we're going to look at port 8080, local host 8080, and we can select the flow, basic Q&A flow, optional, and then we can start the flow. Flow started, ID will be regenerated, active flows, real-time event stream, we're not seeing anything. Flow start requested, and then nothing happens. So we'll have to debug this. But yeah, this is wild. It's kind of wild. I don't know why the flow execution started and then nothing happens, because it looks like flow basic, message type, flow basic requested, publisher successfully published, registered flow worker on the flow type flow basic. Did it register the node after starting the runner? That's like kind of observability system started. I think after that, it needs to call run handlers. So let me quickly just fix that. Why is it creating new windows every time? Anyway, I think this might be the error, which is when registering new handlers to an already running Watermill router, you have to call run handlers, I think. Because if we go to Watermill, just to make sure that this works, and this is the stuff that takes a lot of time to figure out, right? So add handler, and then it is recommended. So I think there's going to be run handlers. If a handler is added while the router is already running, you need to explicitly call run handlers. C, and I'm just going to give it a little bit more context here. Since we're only at 50% so far, because this might actually fix the fact that it doesn't run. This is the kind of, I mean, I've seen this before, so that's why I was able to pinpoint it pretty quickly. That's the other thing that makes like vibe coding pretty interesting, is like how often have you run into these like little things that allow you to deblock the LLM when APIs start to get complicated, right? And then the better way to fix that is actually make an API where it's impossible for register handlers to not call run handler, which is hopefully what it will create here, where register all node workers and register flow worker actually calls run handlers. The thing that is interesting when in the web application, which we'll have to fix, which is when you start a new flow, you should actually create a new router and kill the old one, right? And I am still not like super great at conceptualizing Watermill. I think this is something that my brain just doesn't fully grok, but I think we should create a new router on the same pub sub, I think, as we go. So I think the observability here uses the same router. So I'm going to note this into my to-do to look at for next time is to-do MD is I think the observability system should run its own router runner, and each new flow run should create its own as well. It looks like the file is truncated. Let's see if there are any other methods after this. No, it's not. So why is it complaining? Yeah, I think we're getting down into, I thought this would be like a quick way of doing this, but yeah, I'm not sure what it's doing here. I think run handlers just doesn't need to actually have to run its own subroutine. Yeah, I don't think it needs to run its own subroutine. Whatever, we'll keep it there. I'm gonna add a new thing. Run handlers doesn't need to run in its own subroutine, and I don't think it's needed anyway. See previous point. All right, it's gonna build. It looks like it. Also, it's not able to finish. Exit and cancellation seem to block. That's another one that's like kind of tricky. So let's run it again. Go run web. And then if we start this, we can go there. I don't know why it fails to open the right window. We're going to select the basic flow. We're going to start it. And now we can see, right? Question completed, question XYZ, all pretty good. If we do question answering flow, flow QA chain completed and unknown, cool. Branching intent flow, successful ID will be regenerated. So that didn't seem to have worked. We can verify why it doesn't work later on. So we can see here, branching flow doesn't seem to have worked. Here we do get a disconnected from event stream. And we can run this again. Connected to flow event stream, and we're going to do delay test start flow. Yeah, there seems to be something. Ooh la la la. Ooh la la. What is there? All right, well, going to mark this as well. Delay node test has this error. I also know why it's not killing properly. It's again like a watermill thing. And then we're going to choose the branching intent flow. And this one also doesn't seem to be running. All right. And then branching flow doesn't seem to have worked. And oh no. Okay. So that we already had that. All right, cool. I think that's enough for tonight. So let's commit all of this. Add web observability system that kind of works. And let's push that. And I think we're done. All right. Have fun. Have a good evening. Till next time.